Okay, have you read the last part we had discussed on the previous class from the chapter Matter in Our Surrounding? The primary point, the key points was the matter, what is matter, what are the key characteristics of the matter, that is occupying some space or etc. And another one, that is what is particle, the very important part, that is particle, because this is only the division of matter from where we get the particle. And on the next chapter we will go through the detail of that particle which this particle contains about. Okay, but in this chapter we having the concept of particle. Okay, first point was discussed, that is 1.1.1, matter is made up of particle. This is the one of the characteristics. Now next one, don't mute BMS. Don't mute BMS. If you mute BMS, then you cannot hear anything, because BMS is the me. Okay, next 1.1.2, how small these particles of matter. Okay, so the next point, come to page number, just at the starting, that page number 1. How small are these particles of matter? That is size of the particle. Size of particle. Okay, now the size of particle might vary from matter to matter, but they are having a range. What is range about? The range is not in centimeter. It is, if it is expressed in centimeter, then it might be under 10 to the power minus 45 minus 4 to 10 to the power minus 10 centimeter in this region. Or if we express in meter, then it would be 10 to the power minus 7 to 10 to the power minus 13 meter. This is just a knowledge regarding to that. Okay, now so small is the size of the particle. So if it is so small, so just think about the example from the previous day we have given, that the sugar particles or the salt particles disappeared. Okay, the sugar particle or salt particle disappeared. So when the size of the particle, when it will be greater, that greater means in the region of 10 to the power minus 7 meter. Suppose these are in the range of 10 to the power minus 7 meter, just assume it. So you can see that is the interparticle space. This is the interparticle space. Interparticle space. So the space which is not occupied by the particle and a space which is vacant in between this particle will be called as interparticle space. And if the size of the particle is very less, that is in the range of 10 to the power minus 10 to the power minus 10 meter, then this size can easily take the position of that interparticle space. Okay, so this interparticle space is occupied by the smaller size of particle, and when it is, the space is occupied by the smaller size particle, then it would be called as the solubility. Okay, and the particle will disappear in between the interparticle space. This is the reason behind why the salt or the sugar becomes disappeared after solvation or after stirring. So size of the particle, this is very tiny. Here you can see the examples given. Suppose 2,3 crystal of potassium permanganate. Now potassium permanganate is a dark purple color You can see in your using your internet that potassium permanganate, you can see that It is a very small size crystal or very small size particle. It is found in the crystallite form, and now if just 2 or 3 particles, the very small particle you can see 2 or 3 particles which is easily visible by our eyes, if you place or if you solvate 2 or 3 particles in a glass of water, then you can see that the total solutions turn to a light blue or purple color, light blue or purple color. Just 2 to 3 small units or 2 to 3 small particles. So this light blue color indicates that the 2 or 3 small crystal or 2 or 3 small particle is further subdivided into more particles which is not visible to our naked eyes. So these 2 or 3 particles is not this can be divided further, and this is done when we solvate it, and the total solution becomes light blue or purple color. Okay, now look at the page number 2, figure 1.2, estimating how small are the particles of matter. With every dilution, though the color becomes light, it is still visible. Okay, so when a glass of water turns to a light purple color, if you add more water, you can see that the solution becomes lighter. The intensity of the color of the solutions become lighter, but it can be visible. So the visibility of the very faint purple color indicates that it can be further subdivided. If it is not further subdivided, then the solutions might not be seen as purple. It might be transparent. What type of molecular structure does KMnO4 have? So KMnO4 is crystalline in form, and if you want to know its crystalline structure, that means you have to go to the crystal structure. Okay, so this crystal structure they are having the concept in class 12. This is FCC, BCC, etc. Here in the center this is manganese, and oxygen as a tetrahedral space is occupied. Okay, but according to your level, just know it is a crystalline solid form, crystalline solid. Okay, now come to that portion. The experiment shows that just a few crystals of potassium permanganate can color a large volume of water, about 1000 liters. So we conclude that there must be millions of tiny particles in just one crystal of potassium permanganate. Here crystal means we can distinguish the particle from its gathering or from its form. Suppose we have placed 1 spoonful of KMnO4 in a watch glass, and then using a very small spatula or the tongue, we can easily separate one such particle, which keep on dividing themselves into smaller and smaller particles. So the size of the particle is very small. The same activity can be done using 2 ml of Dettol instead of potassium permanganate. Repeated dilution. What does this dilution means? Anyone having the concept of what is dilution? Anyone having the concept of dilution? Just look at this picture. Suppose it is a sugar plus water. The initial volume of water was 25 ml. This is stage 1. In stage 2, we have added 100 ml of water only, 100 ml of water only, but the amount of sugar remain same. So the extra addition of water, here water is a, so the addition of the solvent increases the volume, but the solute remains the same. Then it is called as the dilution. That is addition of water to any primary solution. If we again add water to this solution, then it is further diluted. Okay? Yes, more water. If the solution is done on water. Okay, now come to the next point. Characteristics of particles of matter. Particles of matter have space in between them. I just discussed about. First point is that the first point is that particle of matter have space in. So when just assume as they are in shape. Okay, now if you observe it minutely, then you can see that there is a space which is not occupied. There is a space which is not occupied. This is called interparticle space. Okay, but if it would be like that, if this is square in there and if it is packed in a concise manner, that is there is no space, then no intermolecular or no interparticle space will be there. But we assume as they are spherical, assuming the particle as spherical in nature, so the spherical nature, in between these sphere they are having some First point, particles of matter are continuously moving. Okay, now particles of matter are continuously moving. Now look at this, there are some activities given. Just look at this. Put an unlit incense sticks. So when the incense sticks burn, then just if you kept it at a corner of a room, at a certain time after, it will spread throughout the room. This indicates the particle, the very small incense particle, can disperse throughout the room. Okay. Next one, take 2 glasses or beakers filled with water, put a drop of blue or red ink slowly and carefully along the side of the first way in the second beaker. In the first way it is a color, that is blue or red, and in the second it is the honey. Leave them undisturbed in your house or in corner of the class. Record your observation. What we will observe, that the ink in the first beaker spread throughout the liquid, and the honey, it would be invisible after some time because it is highly soluble, and the taste of the sugar of the water becomes sweetened. So first the total solutions become colored, and the second case the water becomes sweetened. This indicates that the drop we have added, or the drop of honey or the drop of ink we have added, it further divided and spread throughout the solution to make a change in its properties. Activity 3, drop a crystal of copper sulfate or potassium permanganate. Copper sulfate is also a blue color. So when we will add this copper sulfate crystal to water and we will solute it, then what will happen? The total solution will be colored. Okay. From the above 3 activities and 1.5, we can conclude that particles of matter are continuously moving. Okay. Now how they are moving? They are moving in a zigzag, and all time the particles collided with each another and there is a change in their kinetic energy after each collision, and these collisions are called as elastic collision. Elastic collision, that means there are two kinds of collision, one is elastic, one is non-elastic. Elastic collision, that means after the collision and before after the collision and after the collision and before the collision, the kinetic energy and its potential energy will be same. The potential energy and the kinetic energy will be same. So if it loses its potential energy, then is an increase in its kinetic energy. Okay, so this is called this is also called Brownian movement or Brownian motion. Yes, this is Brownian motion. Okay, next one, they possess what we call the kinetic energy. So what is kinetic energy? Next point, what is kinetic energy? Now this concept will be clear on physics. Kinetic energy, that is energy due to kinetic motion. So when a ball is thrown, the energy is due to its kinetic velocity, and the potential energy, suppose a 1 kg is kept at a height of 100 meter, at a height of 100 meter. So this is, there some energy stored. This 100 meter is from the ground level. So the energy stored here is called as potential energy. When we are ready to throw a ball, that is in this posture, then it is the potential energy. When we throw it, then the potential energy and the energy from our body will be both increases its kinetic velocity or kinetic energy. Yes, 980 joule. This is the half mv square is the kinetic energy, and mgh is the amount of potential energy. Next one, as the temperature rises, particles move faster. Why particles move faster? Because the kinetic energy or the kinetic velocity is proportional to its temperature. Kinetic energy is proportional to temperature. Why? When we will increase the temperature, then the individual particles velocity will increase. So when it will increase, the kinetic energy also will increase. So the second point is that when we increase the temperature, the particle moves faster. It is due to its increasing in its movement and also increasing in its kinetic velocity. We can say that with increasing temperature, the kinetic energy of the particles also increases. This is the reason you can also note it, the kinetic velocity is proportional to temperature. Here temperature is absolute temperature. What is absolute temperature? Absolute temperature is, here it is represented as T, in capital T. The small t is in degree centigrade, it is in Kelvin. Okay. So the kinetic velocity is proportional to capital T, that is absolute temperature. Here absolute temperature, that is minus 373 degree centigrade is 0 Kelvin, and minus 273 degree centigrade equal to 100 Kelvin. It is also a scale to measure temperature, where the least point is minus 373 and the maximum point is minus 273 degree centigrade. Okay. Next one, in the above three activities, we observe that particles of matter intermix on their own with each other. They do so by getting into the space between the particles. The intermixing of particles of two different types of matter on their own is called diffusion. So here you will write Yes, C plus 273 equal to Kelvin. What is diffusion? What is diffusion? The intermixing of particles where the intermixing of particles of two different type of matter on their own is called as diffusion. So intermixing of particles of two different matter of their own is called as diffusion. We also observe that on heating diffusion becomes faster. Why does this happen? This is also due to the kinetic velocity. Okay, next one, 1.2.3. Particles of matter attract each another. Particles of matter attract each another. Yes. Now, this is the number 3 point. Attraction. Okay. Now, the size of the particle as it will be. So, here some interparticle bonding will be there. Why this bonding? This bonding, later on you will know about it. This bonding is greatly known as van der Waals force. On class 11 you having the concept of van der Waals force, but this is also called as cohesive force. That is bonding in between the same kind of particle is called as cohesive force. Another one is adhesive force. Cohesive and adhesive. Cohesive, that is with same particles. Okay. Yes, van der Waals force is a very weak force. Electrostatic, obviously it called be as electrostatic because this is unequal distribution of electron. So when an unequal distribution of electron is there, then there is a polarity is gained. When the polarity is gained, then that means there is a two pole. So when the two poles will arise, then it would be called as the electrostatic force. Yes, same substances is called cohesive force. So what is the sum up of that part? First of all, particles of matter have space in between them. Next one, particles of matter are continuously moving. Particles of matter attract each another. Why they are attract each another? This is due to some polarity gain or etc. And this is broadly called as cohesive force. And another one is that it is due to the polarity. Okay. They are having some activities also, activity 1.6, 1.7, 1.8, which describes about the interparticles binding, and this binding is electrostatic. Okay, so that's all for today's class. So write down two questions, write down it and you will write your answer on the exercise book. Are you ready? Kinetic energy half mv square. Okay, write it. What are the characteristics of particle of matter? What are the characteristics of particles of matter? Here you just mention the characteristics. Particles of matter, only to mention the characteristics. This is number 1. Number 2, what is diffusion? Number 3, why temperature increases kinetic energy. Why temperature increases kinetic energy? Okay. Number 4, describe Brownian movement. Describe Brownian motion. Write it quickly. Question number 3 is why temperature increases kinetic energy, or you can also add why or how. Why or how temperature increases kinetic energy. Okay, so that's all for today.